opinions and defended Fortune 500 clients in the call center space in patent infringement suits. Carl has a Bachelor of Science in Electrical Engineering, a Master of Computer Science degree from Georgia Institute of Technology, and a Juris Doctorate from the University of Georgia. He is also a prolific inventor with over 75 patents. Carl is also a board member of PACE. So now I will turn the floor over to Carl and Michelle.
Thank you, Stuart. And Carl, thank you so much for being on the webinar today. We appreciate your knowledge and your expertise as we talk about this really important topic of shaken and stir and what it's going to mean for our industry. Those of you that know Carl know that he is brilliant and has an amazing communications technology background that has been so important to PACE as we've dealt with a lot of very technology-specific issues lately, not the least of which is shaken and stir. And I'll have to tell you, Carl, when we advertise these webinars as cutting edge, we absolutely did not disappoint today. So for those of you that haven't seen it yet, Chairman Pai just released a new matter for the docket for the June 6th FCC meeting. And he is proposing, and it will be put to vote at that June 6th meeting, that a declaratory order be put in place and then also opening up a new matter for comment. And those issues are concretely around the type of topics that we will be talking about today with Shake and Stir, and about the consumer's ability to block certain types of calls. And the summary of what Chairman Pai is proposing is on the FCC's website, and PACE will be releasing shortly information about this. But in general, it proposes to allow service providers to use call blocking as a default by consumers when offering cellular service. There aren't a lot of details around it right now, but that obviously is a development that needs to be looked at and closely studied, and we will be obviously talking much more about this. Also, a matter was released for further comment around safe harbor for providers that will implement Shake and Stir, and as I said, we'll be discussing that more. Also, Carl, I don't think we mentioned this in your introduction, and to the extent you'd like to say anything about it, Carl was the co-leader of PACE's Communication Protection Coalition. Carl, would you like to just speak just generally about what the CPC did and how that was concluded?
Okay, well, thank you very much, Michelle. I'm happy to have the opportunity to participate. You know, with analytics-based blocking and labeling, there was a concern that mistakes will happen. We all know that they will happen in any kind of environment. And we wanted to make sure that there was a way to mitigate or correct those mistakes, both for the calling party, who may have their calls improperly labeled or blocked, as well as the called party, who wants to ensure that they're receiving the calls that they want to receive and that the calls aren't being mislabeled. So that was an effort that was designed strictly in the analytics-based environment, but in light of the FCC's new order with a safe harbor for carriers that are blocking calls, a similar mechanism has to be defined to ensure that you only get the safe harbor if you are also fixing any mistakes that occur. So I think that's a fair trade. You're allowed to block, but if you make a mistake, you have to give the opportunity for the impacted people to fix it.
Yeah, it's the CPC brought together a lot of the stakeholders early on in this process and gave PACE a voice as some important decisions were making, especially around the topics of Shake and Stir and how the telecom providers were implementing those. So that those efforts, Carl, were obviously greatly appreciated. So before we really get started today, I need to give a disclaimer that Carl and I are not providing legal advice, and we always recommend that individuals and companies get advice from competent legal counsel. And the materials that we provide are informational only, and they don't constitute legal advice. So what's the goal of the webinar today? Well, certainly we want you to understand Shake and Stir by the time we get finished with this webinar. And if there are any topics that you aren't clear on, please feel free to use the chat feature on the webinar tool to ask us questions, and we'll be happy to answer those at the end. We'll talk about what the Shake and Stir is intended to do to address the robocall problem. And just to put this in terms of statistics, the most recent statistics that I have been able to find are validating what we're hearing in the media and from regulators, and that's that robocalling has become a huge problem in that the statistics are showing that 3.7 of all calls in 2017 would be what we consider robocalls. In 2018, that rose to 29.2%, and now they're estimating for the first quarter of 2019 that would be as high as 44.6%. And that's obviously a problem for consumers who are receiving calls that are unwanted and in some circumstances that are illegal and shouldn't be being placed to consumers. And then also on the industry side, it's a problem because as consumers receive more of these types of unlawful or unwanted types of calls, there is an inclination to not answer any phone number which the called party doesn't recognize. So it's making completion rates for our industry much lower on the sales side and also on the customer support side. So it is a problem. The answer to that from the FCC and telecom providers is what we're talking about today, and that's Shake and Stir. And by the end of this, we'll hope that you understand the concepts and have a basic understanding of the technical operations within the Shake and Stir framework.
And as a matter of fact, by the time this webinar is done, I hope that all of you will understand this diagram. It seems a little intimidating, but this is taken from the various Shake and Stir standards documents. And we're going to dissect it piece by piece, and I think you'll find out it's really not as intimidating or incomprehensible as it might appear, and I think you'll understand throughout the seminar how the steps of authenticating and validating a call will happen. But first, Michelle, I understand you've been focusing on some of the legislative tracking of this technology. Can you speak to us about that?
Sure. And I'd point out here that as a member of PACE, one of the benefits that you receive is a report that's produced by our office every month that tracks the state and federal legislative bills and legislation that's passed. That's available on the PACE website, and you'll notice for those of you that have been reviewing the legislative monitoring over the last many years that we've been doing this, that list has gotten quite long. And among that list, you would find these federal bills that have been introduced. There's a number of them, and as I said, they're available on the legislative monitoring summary if you're interested in finding out about each individual bill. For the sake of time today, I don't want to go through all of those, but I think the one that's most worth discussing is the first bulleted one, which is the Traced Act. If you were following the news over the weekend, Representative Schumer announced that he is going to support the Traced Act and is touting a bipartisan support of that piece of legislation, and I think that increases the chances that the Traced Act would move forward along the process with the potential of being passed this year. The sponsors of that bill are Senators Markey and Schumer, Markey and Thune, and as a result of the bipartisan support of that bill, I think it makes it more likely also that would pass. Some of the things that are contained within the Traced Act are an increase in penalties to $10,000 per call, obviously quite a substantial penalty. It increases the time frame that the FCC can bring an enforcement action. Currently that's 1 year, and it would increase it to 3 years. It also would give the FCC criminal jurisdiction over the types of calls, the type of robocalls that are covered by the Traced Act, and that is new. The FCC does not currently have criminal jurisdiction. Also, and relevant to our discussion today, it puts in place an implementation time frame of 18 months for carriers to implement, and it specifically references shake and stir. So we are obviously following this very closely and have made trips to the Hill to have discussions with various committees and members about the TRACE Act, and we'll continue to update you as things progress. So Carl, do you want to frame the robocall problem then for us?
Okay. Yeah, I think one thing we can all agree on, robocalls are bad. No one likes them. We all complain about them. Ironically, there's not a clear agreed-to definition of exactly what is a robocall. Some people think it's any call that's dialed using a computer, even if there's a person on the other line speaking to you. Some people think it's only calls that play a pre-recorded announcement. Others define it as a call made by an automatic telephone dialing system, but there's clear confusion as to what is that, and that's been debating in the courts for years. So we're not quite sure exactly what is or isn't a robocall, but we can agree that the prevalence of Voip technology has made it cheap and easy to make calls, regardless of whether you play a pre-recorded announcement or not. It's cheap and easy to make those calls from anywhere in the world. The equipment can be had with just a personal computer and a high-speed internet connection. Once you have a carrier that's willing to provide services to put those calls onto the telephony network, you can literally originate hundreds of thousands of calls each day. One aspect which is frequently common on all these robocalls is that they rely on spoofing, and that's because these callers want to hide their identity. And Michelle, can you tell us a little bit more about exactly what spoofing is? Because, again, there's no standard definition of this term.
There isn't, and you know, we as an industry, as we've been addressing these issues, the lack of a clear definition that even all of the regulators agree on for things like spoofing or robocall has obviously presented some difficulty. With regard to spoofing, generally it's viewed as using any telephone number in call origination that can't be directed back to the same individual whose number is represented by the calling number ID. So unauthorized spoofing would be using someone else's number without permission, and that usually would be illegal. There's also authorized spoofing, and there's a lot of legitimate reasons that businesses would display a number that isn't the actual number being used to place a telephone call. For instance, even in the regulatory compliance arena, you are required to provide a telephone number that will accept a do not call request. So frequently when outpulsing a caller ID number or a display, companies will show a number that will allow that do not call request to be directed to a central location. Contact centers might be using the caller ID of the seller that they're placing calls on behalf of. So there are many legitimate reasons that you would want to alter the caller ID from the number that's placing that telephone call. So identifying exactly what would be a harmful type of spoofing versus the type of spoofing or manipulation of caller ID that would be wanted and also allow us to be in better compliance is not always an easy thing to do. That is one of the significant reasons that regulators and the telecom industry has looked to Shake It and Stir to help provide a mechanism that will identify with certainty who the called party is, and hopefully it would eliminate unauthorized or unlawful spoofing in that would be prevented and the call would not go through, or at least would carry some type of label that would indicate that there might be issues with the type of call that's being placed. At the bottom of the slide, you know, we laughed when we first heard the acronym Shake and Stir, obviously a nod to the James Bond character, and they had to get kind of creative to come up with that acronym. But signature-based handling of asserted information using tokens is what Shaken stands for, and then Stir is secure telephone identify revisited. So that's, if you're ever asked what the acronym is, I'm sure you'll have to look it up, but that's what it is.
Okay. I think the easiest way to explain how Shaken and Stir works is to analogize it to the process of notarizing a document. Typically, parties want to enter into some sort of agreement where the originator wants to sign it, provide it to a remote recipient. The recipient wants to make sure that the person who signed it is the person who they're expecting it to be. And so this is where the function of a notary comes into play. The notary is a person whose job is to attest that the individual signing the document is that individual. And the process, as many of us know, is the individual presents some sort of ID, a driver's license, passport, to the notary. If you have a notary in your company, they may personally know you, so you don't have to present an ID, but they know who you are. You sign the document, and the notary takes out a seal. It used to be, it embossed the paper. I think the modern ones now just print the seal on the paper. And it's affixed to the document, and the document is mailed. The recipient, by the presence of the seal, knows that that document purportedly was signed by the person indicated. Some salient points that we'll see reflected in a corresponding framework in Shaken and Stir is that the notary is placed in a position of trust by some authority. It's actually by the state, frequently under the auspices of the Secretary of the State. That notary has to perform the duty of vouching for the identity of the person who's signing it. The presence of the seal means that the notary was there and vouched for the signer's identity. By putting the seal on the document, it's difficult to forge. That probably a little bit easier now given modern technology, but the presence of the seal is intended to indicate, yes, this process occurred. And we know the name of the notary because in days past, the name and their number was indicated on the seal. So if it turns out we have a problem of a rogue notary not doing their duty, we would know that because they're identified on that seal, and we could revoke their seal, or the seals would have an expiration date. We could not reissue them a new one. So that was a way to police the process. It's not completely foolproof, though. Correct, Michelle?
No, not. And we have a whole lineage of cases around notarizing of documents and whether the notarization actually authenticated a signature. And there's a lot of reasons that notarization might fail, and that is that the ID used to identify who the person was may not be an actual ID. It could be a fake ID. The notary may have failed to even properly identify the person that is signing the document on whose signature they're notarizing. Maybe they didn't present, or maybe the notary didn't request an ID. Also, it could be a different person with the same name that could present a valid ID. There is the ability to have forged seals on these type of documents, and a document could even be tampered with to show a seal. So there is no notarization system that is completely foolproof, and you'll see with the corresponding Voip architecture as we discuss this that we could have the same types of problems with Shake and Stir.
Yes. So keep those problems in mind. It turns out those same types of problems have to be addressed in the Shaken and Stir architecture. So this is the basic Voip architecture, very, very much simplified. The caller will submit a call request to the originating telephone carrier. It could be a cable company or any other type of VoIP carrier. There could be one switch in that originating telephone carrier company. There could be multiple switches or routers or other types of devices, as they're called. Those calls are then sent to a terminating telephone carrier. In this case, it's going to a wireless end user. We can use this as a base architecture. This doesn't do any of the authentication or validation, and that's the problem, because the caller, in this case, as shown as a handset telephone, but it could be a PBX, indicates the number, their calling party number, in a message. It's called a SIP invite message when they want to originate a call, and that could be false. So we have to have a way to authenticate that. And in order to do that, we're going to add, on the originating telephone carrier side, an authentication service, and conversely, on the terminating carrier, we're going to provide a verification service. So you can think of the authentication service as making the seal to the call, and the verification service as validating it. And what we're really validating and authenticating is the calling party number. Now, those services could be done within the switch in the carrier. They could be done by a separate computer adjacent in the same data center, or they could be provided by a third-party service provider in the cloud. We'll probably see a variety of these types of implementations as time goes on. So, Michelle, to complete the analogy of this architecture with the notary, I'll let you describe that.
Yeah, so that seal that's placed next to the notary's signature, that would be the same as a signed token in the architecture as Carl has explained it. You replace the notary with the authentication service. The signed party would be the caller, or if some type of enterprise system, potentially a PBX. You'd replace with the word recipient with the called party or the terminating carrier. So whoever would be receiving that document in the notary setting is what we're talking about as far as a person receiving a call. And then also replacing document with a phone call. So, you know, if you think of it in those terms, I think it makes it a little bit easier to understand the very complex communications, technology, and engineering that's happening behind the scenes in Shake and Stir.
Okay. Michelle talked about a token. They're also called a passport token or simply token. It goes in an element called the identity header, so it's sometimes called the identity header. But it's basically 4 types of information that are encrypted. It has the calling and called party numbers, telephone numbers. It has a date and time stamp. It has an origination identifier, and this is going to be a very, very useful piece of data. It's a unique global identifier that identifies the carrier and the customer or interface within that carrier that originated the call. And finally, there's the attestation level indicator, sometimes also called an authentication indication. This indicates whether the calling party number is spoofed or not, or the level of authentication. I should back up and mention that when the originating telephone originates a call, as I said, it originates a SIP invite message, which includes the calling party number and the called party number. That is separate and distinct from this token. So the calling and call party numbers are both in the token and both in the SIP invite message. We'll speak to that a little bit later. The way we encrypt these tokens are using digital certificates. This is the digital information infrastructure that's used to process the messages so that we can ensure that they're not changed or they're not forged, or we know that we know that the person who sent them actually did send them and no one else corrupted the contents. It involves using a private and public key pair, and you may have heard of this kind of technology used in other types of communications, such as internet communications. It's fairly well established. As you can imagine, the private key is secret, and the public key is readily available by the recipient. So the sender has to get a private key and keep it secret, and if it's somehow divulged, then you have to get a new one. You need to keep that very protected very carefully. The process for using these keys is a little bit more complicated than shown, but this is, I think, sufficient. You can take a message, any type of binary message, process it using a private key, and what comes out of this process, which is called signing, is encrypted information. And you can send that, give that to anyone, as long as the receiving entity has the corresponding public key, they can decrypt that information and get the original message. If it turns out that that information has been changed, it can be detected. If it was forged by someone else, it can be detected. So it's a fairly robust architecture for encrypting information. Now, you can imagine that, going back to our architecture, the authentication service needs to have access to this private key, and when a call is originated, it will take that private key and encode the information, and correspondingly, the terminating carrier that receives the information, its verification service has to use the public key to decrypt it. Next, Michelle, can you tell us a little bit about this attestation indicator?
Yeah, and this will become important as we talk about what the experience for the call recipient will be, because that will be affected by what type of attestation or what type of token is being provided, or what type of token is being provided throughout the process. So there are 3 levels of attestation. One is a full attestation. I would think that that is the level that most of us on this call would be attempting to obtain. And basically what we're saying with a full attestation is that the service provider has authenticated the calling party and that they're authorized to use the calling number. An example of this would be a subscriber registered with the originating telephone service provider's soft switch. So basically, with a full attestation, you know the person that's or the entity that's responsible for the call origination. They would have generally a direct, the authentic authority would have a direct customer relationship, and they verified the association with the telephone number used for the call. There's also partial attestation, and with partial attestation, the service provider has authenticated the call origination but can't verify the call source, is authorized to use the calling number. So an example of this might be a telephone number behind an enterprise PBX. That would present or could present a partial attestation situation. And then there's gateway attestation, and with this, the service provider would not know who's responsible for the call origination. They wouldn't have a direct relationship with the customer, and there's no verified association with the telephone number and the person who's placing the call. An example of this would be something like a call that's coming through an international gateway, and we don't have any of the information that would be required to provide an attestation for that number.
And one other point to add is that if you get your number from the carrier and you originate the call to that carrier, they're able to give you the full attestation. If you got a call from a carrier but you're using a different carrier now to originate the call, you probably would get partial attestation because they can verify you as a customer but not the number. Okay. Now the other piece of information that's very important and useful is the origination identifier. As I mentioned, it's a globally unique point of origin indicator. There's an information that identifies the originating carrier via an OCN operating company number that's allocated under the auspices of the FCC. And within that scope of the operating carrier number, that carrier can define their own interface identifier. Whether they want to allocate it to a particular customer, a particular interface, or however. But with this origination identifier, we now know which carrier originated the call, and we can go to that carrier and say, tell us which customer or which interface this particular call originated. And that's on every authenticated call. That is extremely useful and important for traceback purposes. That tells us who the caller actually is for any particular call. Important to this overall scheme is what I call the various authorities. It begins with the FCC, and the FCC has various industry groups under it. One of them is the North American Numbering Council. When Chairman Wheeler started a task group to address the robocall issue, it was this group that addressed that issue. And out of that task force, they recommended that a governance authority, GA, be set up. That governance authority would define the overall ecosystem for how to deal with robocalls, including defining shaken and stir, all the policies, the procedures. The GA has been formed. There are maybe a dozen or so individuals. They work full-time jobs at their respective companies. The GA members, the board has been selected from the industry, including, Voip providers, cable providers, wireless providers, wireline providers, and so forth. So they represent the industry, but they don't do the day-to-day work. That is going to be the function of the policy administrators. So the policy administrators will actually implement and carry out the policies as dictated by the governance authority. They're going to do various functions. There's actually an RFP that was sent out by the governance authority earlier this year, and sometime this month they're actually going to award the contract as to which company will be the policy administrator. One of the things that the policy administrator will have to do is oversee and monitor the certificate authorities. The certificate authorities are the ones that manage and provide certificates, including the public-private keys to the service providers. Now, if a service provider wants to get a certificate, they're going to have to ask first the policy administrator for permission, and the policy administrator will actually vet that service provider and say, okay, you can have a certificate, and in order to get that, we're going to give you a token, and you can go to a certificate authority, and there may be several of them, and when you show them their token, it shows that you're now approved to get a certificate, so you can sign calls. So that kind of a triangular relationship ensures a check and balance, and that there's adequate trust in the certificates that are being assigned. Okay, so there's one other part in the architecture we're going to fill in, and that's this analytics option. The analytics option isn't really defined as a mandatory element in the shake and stir. It's put there as a placeholder, recognizing that when you do all this processing on a call that's coming into, let's say, the wireless subscriber, you may go to an analytics service provider and check, is this call telemarketing? Is this call potentially a problem? Has this originating carrier been letting calls out that maybe they shouldn't have been? It's not part of the shaken and stir framework, but it is recognized that it is a process that can occur. So looking back at that original architecture, I've taken out some of the extraneous labels. This was the architecture we started with. And without going into all the acronyms, these entities are SIP user agents, which are really the end user equipment, PBXs, phones, mobile sets, smartphones, and so forth. So that's that part of the architecture. The other part of the architecture was the call session control function, the transition gateway, the interconnection border control function. Those components, I think we can just replace them with the switch or the carrier's equipment. And finally, the STI authentication service and the secure telephony identity verification service we can replace with those boxes we already saw. The SKS is the secure key store. The STICR is the secure telephone identity certification authority. And the CVT is call validation treatment. Those are really keys and analytic providers. So this figure corresponds to the original one we saw, and you now understand it. So let's go through and see how a call would actually go to make sure we understand all the steps. Step 1, a phone, the caller will originate a call request that is using the conventional method called a SIP invite message. That will indicate the calling and call it numbers. The originating telephone carrier has to then take out that calling and call it party number. It will verify, is this device really that calling party number? And there are a number of ways that can be done. It could have a list of numbers that this interface is allowed to use, or it could actually simply trust the device. But it will provide that information to the authentication service, which then uses the private key that's securely stored to encrypt that information and create a SIP identity header, which is then passed down to the switch and sent off with the SIP invite. And this process happens in just milliseconds, so it really doesn't delay the call origination very much. The process essentially is reversed at the terminating telephone carrier. It will take off that identity header and send it to the verification service, which then will go out and retrieve the public key corresponding to the private key used by the caller and verify the information in the identity header. And obviously, the calling and calling party number in the identity header should be the same as the calling and calling party number in the SIP invite header. So if that occurs, obviously there's been no tampering. It can then process the attestation indicator in a manner as defined and then offer the call to the called party. Now, probably when this call is offered to the called party, that terminating telephone carrier will provide some sort of indication of the outcome of this process. So Michelle, what will the called party see?
So I don't know that we fully know the answer to that yet, in that the standards have not been fully agreed to and developed. But what Carl has prepared for us in the slides here are what someone might see on their smartphone device when they receive a call that has gone through the authentication process. So maybe something like a check mark that says, yes, this is a fully attested to telephone call, and they have been able to verify the number, versus a partially authenticated phone number or one that was not able to be authenticated. There's an interesting opportunity here also as to what also can be done with the display that the call recipient would receive. If there's the ability to send these types of images through and to provide information about the call like this, then there's also the ability to see potentially something like this. Maybe it would be a company logo, and maybe it would provide information about the purpose of the telephone call. And the term used for this is enhanced caller ID. And although we don't have any concrete standards around this concept yet, it is most certainly something that is being discussed as the engineers are developing the architecture and the displays for Shake and Stir.
Yeah. And I think my personal opinion is that the wireless carriers, because this shows a smartphone, will want the flexibility to provide different types of information. We may not get it right initially. We may put too much information. We may not put enough. And that flexibility, I think, is desirable because the marketplace may dictate how much and what type of information should be presented to the call party. I think that if people find out that the call numbers are fully authenticated, some of the other information, such as calling name delivery, becomes very trusted and worthwhile, and that may be sufficient for the person's needs. We'll have to see. I think the carriers do need and want the flexibility to experiment to see what's the best type of user interface that people want. Now, there are a couple pitfalls we have to worry about. It's not clear how quickly all the VoIP carriers will deploy this technology. Some carriers that are non-VoIP, and I'll call those conventional telcos, many of them are in the rural areas, they're not directly Shake and Stir compatible because Shake and Stir works with VoIP. So if they're not VoIP, they may have to have some sort of workaround. And the problem is that that technology that they're using is, frankly, old, obsolete. Some of the companies may not be in existence, so you can't get a software upgrade easily for this type of infrastructure. The solution might be to replace the infrastructure with VoIP. So that's a question. And until everyone implements Shake and Stir, called parties will receive calls that are unauthenticated. So if Aunt B from Mayberry calls you, your aunt in the country calls you, and their telephone company is not Shake and Stir compatible, that call will either not be authenticated or will come in as a gateway authenticated call. And that looks a lot potentially like an overseas scam robocall, which will be gateway attested to. And if you automatically block unauthenticated calls, that could create severe issues during this transition time. And that's I think, a legitimate concern and a reason not to mandate blocking of unauthenticated calls until we have a better handle as to how this transition occurs. I think we can expect carriers will offer a variety of services to their subscribers. They may offer services such as will block calls, or will send them to voicemail, or will do some other neat things. So I think that flexibility is something to look forward to in providing convenience to us.
One of the reasons that the Shake and Stir architecture was so attractive to regulators and others is that it's got many built-in protections. Under the current telecom ecosystem, it's very difficult to trace back fraudulent callers and scamsters, especially if they're calling from overseas, and that has been a huge frustration for the regulators as they've tried to eliminate the IRS scam type of calls. So under Shake and Stir, there will be built-in protections that will provide an arsenal of tools for regulators and others. And so let's assume that an authenticator is authenticating calls that are from a shady call originator. What happens? we'd assume in this situation that the call had received a full attestation, meaning that we knew who was calling and could validate that it was the telephone number that belonged to them. And then after the telephone calls are made, we find out that even though there wasn't a full attestation to this call, that maybe their products or services had issues, or maybe they were actually providing some type of scam product, then what it would give the ability of the regulators to do is to trace back who actually placed that telephone call. So you'd have the caller's telephone number and the originating carrier's identification, and then you'd also have the interface from the carrier to the call originator. So basically going backward in the architecture that Carl has explained. And then that allows for many remedies for somebody engaging in this type of unlawful or unscrupulous behavior. Legal action could be taken either public through a regulator or potentially a private lawsuit. The originating carrier certificate could be revoked. It would call into question their ability to properly authenticate and attest to telephone calls, or the carrier could terminate the service to the caller. So many things that Shaken and Stir allow us to do that aren't currently available under the telecom architecture that we have. It's very difficult to trace back calls under the Voip architecture.
Okay, and I know we have 10 minutes left, so I'm going to try to speed this up. Let me just say one point. We're fortunate that the engineers had the foresight to build in flexibility. Let me go back to the example of the Notary Public. At my company, the notary knows me personally, so I don't have to provide an ID and they'll notarize a document. The standard doesn't define how the originating switch has to authenticate the calling party number. And I know it's a little bit of a surprise, but some carriers will trust their customers to use the proper number and essentially say, we'll fully authenticate it because we know that you're a large enterprise, a large bank, or whatever, and we trust you. And if there is a problem, we'll know it, we'll trace it back, and we'll demand that you fix it. And this level of trust can actually be manifested in the terms of service, contractual obligations, that if a carrier says you want to use our service, you have to warrant and represent that you're going to only use numbers you're authorized to use, and if you violate that, we can disconnect your service or we'll assess damages. And so this allows the policing to actually be shifted from the carrier to the call originator in certain cases. There's also other flexibility, as I mentioned, in regard to the traceback. I think Michelle covered that, so let me go to the next slide. To summarize, Shaken and Stir allows us to identify numbers that are spoofed. Carriers will be able to provide new services based on that information. Shaken and Stir will bring trust back to the telephone network. And other services such as calling name delivery can now be trusted because the number, calling party number, can be trusted. So we expect that Shaken and Stir will facilitate other types of services and bring trust back to the telephony service. But there's some things it won't do, and Michelle will tell us about that.
Yeah, so you won't know specifically who's placing a telephone call. You'll know who the originator is, and you'll know that the person using the number was authorized to use that telephone number. It won't tell you why somebody is calling. It will only tell you if that call has an attestation level and what that level is. It can't stop the caller from perpetrating a scam. It will allow us to have some enhanced traceback features, but it won't actually stop that. Or would it stop somebody from violating the do not call list? There is no type of scrubbing function built in for do not call compliance.
And we can expect this to happen probably. I know the FCC has asked carriers to deploy this by end of this year. But realistically, we'll probably see the main deployment next year. And I'm sure carriers will be creative in the technology.
God bless you, Carl. I think you're sneezing over there. Yeah, and
well,
we do know from if the trace. Go ahead.
I was going to say, and that brings us to our Q&A.
That's right. That's right. We do know, however, though, if the Trace Act passed, it's going to implement an 18-month time frame for implementation, and who knows when that will happen, and that time frame could be changed before a final bill was passed. So I do see that we have a lot of questions here. Stuart, do you want to lead us off with questions?
Okay, so the first one was realized not legal advice, but like thoughts on this. TSR allows substituting the customer service number of the seller in the telemarketer's outbound call on behalf of that seller.
Mm-hmm.
If telemarketer uses his own call center number, does that essentially satisfy the requirement?
So the TSR makes it a violation to fail to transmit a telephone number of the telemarketer or the carrier that the telemarketer's telephone number. You can substitute, however, the seller's number. So unless I'm misunderstanding the question, if you are using either of those numbers, then that would allow you to comply with the TSR.
I think the other question is, if you use a number of your client, will your carrier fully authenticate it, or will the carrier say, I know who you are, but I don't know this number, and so I'm going to give it partial attestation? And that's a question that we're anxiously awaiting, because some carriers might want to see proof that the caller is authorized, and upon that proof, maybe they'll fully authenticate it. So that's a very important question.
How does the contact center get the private key? Has that been established yet?
Well, under this scheme, the contact center, the caller, does not get a private key. It's the carrier. And there is an alternative scheme being talked about a different type of key that's associated with a number. I think that there are a lot of questions and issues associated with that, but under this scheme as defined, only carriers get the key and sign calls. So
that means the call originator, that's not the call originator, that's the carrier. So are the carriers, is there a cost to them? But there's no cost to the call originator.
I was on a call yesterday, webinar from Asta, from the Governance Authority, and they're talking about how to fund this activity and whether or not carriers will pay a flat rate or a percentage of their revenues, or how costs will be recovered, because the certificate authorities will have to be a business, and they have to make money, and managing these keys is not going to be free. So yeah, there will be some cost associated with it.
And how will Chicken Star interact with the existing carrier-provided solutions like Hiya, Nomo, Robo, and First Orion?
I think that's a very good question. And there's some talk, I heard the other day, that based on the originating operating company number, the originating carrier, these analytics companies could maintain a reputational index and use that as an additional input in labeling calls. Other people have raised questions as to what is the value of a label if you have an authenticated number and a name. Does the label add very much? Michelle, do you have any thoughts?
Well, actually, I have a question for you, Carl, and I'm wondering if in some of the recent ATIS meetings it's been discussed. So one of the issues early on with Shake and Stir was the ability for the tokens to be carried through various PBXs. And I know that there was some concern that maybe not all PBXs would be able to do that, to be able to transmit tokens. Has there been any additional developments or discussions around that? Are you hearing anything from the technology providers?
Well, what's I think probably a more significant problem, similar, is whether the intervening network elements can carry the tokens. Because it has to go from the originating switch to the terminating switch, and along that path there may be, half a dozen pieces of equipment or a dozen pieces of equipment that have to handle this message, the SIP invite message, with the identity header. And there is a limitation. Some of that equipment, as I understand, will not handle very large SIP invite messages, and it'll strip off extraneous headers. That's more of a problem in the network than I think in the PBX at the moment.
It's top of the hour, but we have two other questions, so let's stay on if Carl and Michelle, you have time?
Sure.
Yeah.
For these two last questions? Okay, how will Shake and Stir work with landlines?
Well, if you're, let's say you're a customer of a cable company, which is a Voip provider, and they provide an adapter for your conventional telephone device. Frequently that adapter might have a calling line display, and people have talked about, well, maybe we'll display the letter V before the number or the calling name, and the V will indicate it's validated. So it's possible, if you're a Voip subscriber at the called party, to get the benefit of this service. If you're a landline customer, that's the old conventional TDMA, POTS telephone, Shake and Stir doesn't work very well. It only works with Voip providers.
Okay. And lastly, will services such as Newstar be able to effectively removing tags via tokens, work directly with carriers?
I'll let you answer that one first, Michelle.
Oh, I'm sorry. I'm sorry, what was the question?
Well, I'm not. I think it's a separate issue as to how you label or correct a tag. I think that's what's being meant. Using Shake and Stir, I think they're separate, and so you could probably do a better job, and you could probably make more mistakes. So I'm not sure whether Shake and Stir would necessarily allow someone to do it better or worse.
Anything else, Michelle, on that?
No, nothing to add.
No? All right, well then, that's all the time we have for today, and I would like to thank Michelle and Carl. This is really a very informative webinar. The recording of the webinar will be available on the PACE website in just a few days. A reminder, the 2019 PACE Washington Summit is September 22 to 24, Intercontinental on the Wharf in Washington, D.C. Our early bird registration is open, and other information about the summit can be found on the website. We will also be having a day-long regional event in Akron, Ohio, Wednesday, June 19th. This event will encompass topics on compliance and operations. Information about the event and registration can be found on the PACE website. And don't forget to check out all the other membership opportunities on our website, like our benchmark portal, operational certificates, online resource directory, opportunities to submit content. Hope to see you very soon at another PACE webinar, National Regional Chapter event. Remember, these compliance seminars are only open to members, so if you're a Noble customer, not a member, you will be receiving an email for a special offer if some of these webinars really make sense for you. So thank you, and this is Carl and Michelle, and everyone have a great day.
Thank you, Carl.
Thank you, Michelle.